Okay, so guys, welcome back. Now I'll try to explain how to do a two clustering with minimum cuts and balanced weight. So these are the same points, the same nodes we had in the first question. I just posted the video. And now we are provided with weights. So you see the weights on every node and also with the agency uh, matrix. So we have these connections between the nodes of the path. Okay. So we'll try to find a way to get um, the clustering with the minimum number of paths. Okay, and balance it. So we suggested a kind of pseudo algorithm to follow. So we said, like we said previously in question one, we start with one single node in each cluster and pick the node with the most adequate weight to add to each of the clusters, current center weights, update the center with coordinates, and repeat till all nodes are assigned. So here, I'll say that these are my two clusters, P and Q, and I'll do a small initialization in iteration 0. I'll start with iteration 0, and here I'll count the weight, okay, the total weight at every iteration. And of course, here I will list the nodes for my cluster, and here the total and the nodes in my cluster. Okay, so let's do it. So I'll start with just a small observation here. Okay, the problem is quite easy to solve because you can already observe that in fact we have here 4 nodes with 12 total weight, and here we have 6 nodes with 12 total weight. Okay, well, how to guess this? Now, if you count on the total number of nodes, you have 10 nodes, but the total weight is 24. Okay, so to do a balanced cut or a balanced clustering, the best way is to assign to each cluster is total node of total weight of 12. Okay, and here we have already this solution, which gives you, in fact, a minimum cut, which a number of cut, which is equal to 1. If you cut here, you have a minimum cut. Okay, so basically the best solution is apparent. Now I try to seek a way to just to follow the algorithm and get it. Okay, what was suggested here in the question in the homework, it said that you can do different initialization, iterate, and well, you might reach the best solution. Well, fine. Now, here what I'll start with is to assign to my first cluster, which is P, the node 1, okay? And here my total weight would be just 2. And here I'll put just node 10. And my total weight is 2, okay? Now, for the next iteration, or what is called the first iteration, I will add a node. So up to now, how many cuts do we have? We cannot determine because there is no link between 1 and 10. There is no direct link between 1 and 10. Okay, but once you add to node 1, you add 2. You have a total weight of 4, and here I'm adding node 9, so I have a total weight of 6 instead of 3. Okay. Still, I have no connection between the two clusters. Now I'll move on with the 6th iteration. I'll add node 3. So I have 6. Now, the two clusters are balanced, but I still have nodes to use. So I'll have to add here node 8, and I'll get 9. So I'll move on, and I have to add a fourth node here, which is node 4, and I'll get total weight of 8. It's quite close still. Now I'll add node 7, I'll get to 12. And the fourth iteration give me a total weight of 10. And finally, I can see that only way to balance it, I will add a fifth iteration. I will have a total weight of 12. So basically, here I can see that I got my solution. I get the total number of cuts, which is 1 cut, which is the minimum you can reach because your graph here is connected. And this is the minimum number of cuts you can reach with a balanced total weight at comparing to each the two clusters. Thank you.